going to talk about electric power versus electric power. When a voltage is applied to the circuit, so if we're going to apply the voltage, so it's going to cause the current to flow because the electron going to flow, but there will be resistance in the time t. So the total charge q flows in time t is equal to q is equal to I t. So now we're going to make the full electric power because if you're going to say that the charge is going to move, the charge is going to move there. So now we're going to say that the charge is there. So charge is going to be like the IT because how much of the current is going to go through the time second. So it's going to be like that. Q is equal to IT. So from where we're going to, we know that we're talking about the voltage there, which is like the voltage V. We're going to talk about the I. We're going to talk about the resistance. So what about the V, man? Like if you can say V is equal to W by Q. How many work done you're gonna do on a charge? So W is gonna be like VQ. So V is just like V, but Q had the value. What the value of Q? It's like IT. So W is equal to VIT. It's the it's the thing there. Like you can check it out here. This work in moving the charges in the time t is called the electric part, or the rate at which work is done in an electric circuit is called electric power. Electric power, the formula of electric power is work done in electric circuit divided by time. Like how much of work done you're gonna do on electric circuit divided by the time period there. Now we know the power formula. The power is equal to work done in time. Like work done in time is equal to power. So already we have the work done. We have VIT. So it's gonna be divided by this. So it's P is equal to VI. So if we're gonna put V is equal to IR as we know, so it will be like I square R. So another formula we're gonna use here, P is equal to, if you're gonna put the value of I, so what the value of I will be, V our I is equal to this. So if you're gonna use V times V divided by R, and here's also I, so you're gonna V squared by R. Okay, so V squared by R is the thing here. Like we have to put VR, so in this place, so V divided by R is equal to V squared by R. So it is also the formula of electric power. So there is one more thing we're going to talk about here. A unit of the above three formulas are equally valid for calculation of electric power in a DC circuits. Which one is to be used depends simple upon on the known quantity. Yeah, if you're gonna have the quantity V and R, then we're gonna use the formula. If you have only IR, then we're gonna use this. If you have VI, then you're gonna use this. So three formulas are there for power calculation or electric power calculation. So unit of electric power. So that's the unit of power is watt. Of power or 1 watt is said to be consumed in a circuit if a potential difference of 1 volt, if 1 volt is there and it's gonna cause 1 ampere of current through it. So 1 watt is equal to 1 volt multiplied by 1 ampere. The bigger unit will be 1 kilowatt, 1 megawatt, etc. So like, what is kilowatt hours? In which our energy is measured in Pakistan. So electric energy is commonly consumed in a very large quantity for the measurement of which joule is a very small unit. Hence, a large unit of energy is required, which is kilowatt per hour. 1 kilowatt hour is commonly termed as one of the commercial units for electrical energy. It is the amount of energy obtained by a power of 1 kilowatt in 1 hour. Like kilos multiplied by 10 raised to the power 3. R, so R has about 3,600 seconds. So we get a multiplier. So it will be 3.6 multiplied 10 raised to the power 6 watt per second. And 1 joule is equal to 1 watt per second. So it will be 1 kilowatt per hour, which is 3.6 multiplied 10 raised to the power 6 joule. So here was the topic about the electric power. Hope you all understood this topic.